right, so in this lesson, we're going to put together our new rules for integrating e to the x and ln of x, along with our evaluation of our integrals using u substitution. So putting several things together in this lesson, but all the rules that we talked about still apply. So when I rewrite this integral x times 2x minus 1 to the negative 1/2 power, you can tell that probably the best choice here for you is the 2x minus 1. So du is going to be 2 dx, and I don't have a 2 in here, so I'm going to divide by my 2. So dx is going to be du over 2, but I also have an extra x in here. So remember, that's where we rearrange this so that we could solve it for x. So we know that u plus 1 equals 2x, so I'll divide by 2, and I can replace that x with u plus 1 over 2. I also need to create a table so that I can change my values. So I guess I'm kind of running out of space here, but we'll do it up here. So here's x, here's u. We're going from 1 to 5. So if I put 1 in here, that would be 2 minus 1 is still 1. I put 5 in here, that would be 10 minus 1 is 9. So I'm going to rewrite this as the integral from 1 to 9. Where the x is, I'm going to put my u plus 1 over 2. Then I have u to the negative 1/2, and where the dx is, I put du over 2. All right, so when I take out this half and this half, I have 1/4. The integral from 1 to 9 of u plus 1 times u to the negative 1/2 du. And so now I need to distribute that. So I'm going to have 1/4 times the integral, and u to the first. So when we multiply, we add the exponent. So 1 plus negative 1/2 would be u to the 1/2 plus 1 times u to the negative 1/2 is u to the negative 1/2 du. So now I'm going to evaluate the integral, or, well, this is still from 1 to 9. Let me go ahead and integrate, and then we'll evaluate. So when I integrate that, I'm going to get u to the 3/2 over 3/2 or times 2/3. And then this would be u to the 1/2 over 1/2 or times 2. And it's minus, minus never mind. Plus, I thought it was going to change the sign, but it's not, because it's u to the positive 1/2 over 1/2 or times 2 over 1. And we're going from 1 to 9. All right, so we're going to do some mental math here. We're going to plug in 9 first. So the square root of 9 would be 3. 3 to the 3rd power would be 27. 27 divided by 3 would be 9, times 2 would be 18. And we're plugging in 1. So 1 in here is just going to give me 2/3. So 18 minus 2/3. Sorry, 18, not minus 2/3. The 2/3 comes here in a minute. 18, and then I got to plug the 9 in here. So the square root of 9 would be 3 times 2 is 6. So plus 6, and then minus, now then I plug in my 1. I have my 2/3, and then 1 in here would be plus 2. I guess I need another bracket. All right, so we have, well, I guess I do need times 1/4. So 18 plus 6, so we're going to have 24 minus, and then 2/3. Oh, I could have done just minus 2/3 minus 2. So that's going to give me 22 minus 2/3. All right, so that's going to be 66 thirds minus 2 thirds would be 64 thirds. 1/4, 64 thirds, and 4 going there 16 times, so 16 thirds. All right, so other than the just mental math, up here, remember that we chose the inside function as u. Because we were doing u substitution with a definite integral, we had to change our u values, make all your substitutions and integrate, and then evaluate. Hopefully I won't mess up quite so many times on the next example. So here we go. All right, so on this one, it looks like we need to let the exponent be our u value. So du equals 2x dx. I have the x dx, so right here, I just need to divide by the 2. So we're going to have the integral of e to the u du over 2. And I also need to change my values here. So we're going from 0 to 2. 0 squared is still 0. 2 squared would be 4. So now I'm going from 0 to 4. All right, so we're going to have 1/2 times the integral from 0 to 4 of e to the u du. When you integrate e to the u, you get e to the u. So 1/2 e to the u from 0 to 4. So 1/2, plug in the top first, e to the 4th minus e to the 0. And so 1/2 times e to the 4th minus 1. And so if I put both of those over 1/2, I just have e to the 4th minus 1 over 2. If you write it separately, e to the 4th over 2 minus 1/2. All right, so just to recap on that one, we let the exponent be the u value. We made our substitutions. We also substituted in our new values for integrating with respect to u. All right, one more of these examples. So this one, we've just got the integral of 1 over x. And remember that 1 over x, if we were to rewrite that as x to the negative 1 power, it's one of those that's supposed to give me the red flag. Because if I add 1, I'm going to get 0. X to the 0 over 0, you cannot do that. This one is just a straight evaluation of the integral. So when I evaluate 1 over x, I get ln of x. And I'm going to evaluate that from 1 to 3. So I have ln of 3 minus ln of 1, and probably all of these should have an absolute value. We've got ln of 3 minus, remember, e to the 0 power is 1, so this is just 0. So I really just end up with ln of 3. And 3 is a positive number, so I could drop off the absolute value.